Okay, so I'm live here with 52 weeks of Swift, and I'm going to cover subscripts today. And I'm going to go ahead and share my screen here, get right into it. So let's go ahead and start here with subscripts. The idea here of a subscript is that you can define a subscript, which is a shortcut for accessing the member elements of a collection, a list, or a sequence. You can use these subscripts to set and retrieve values by index without needing a separate method for setting and retrieving, like getters and setters. So you can access an array by using kind of a classic syntax in Python or other languages, where you put in the square brackets, and the elements in a dictionary are in a similar way. So the subscript syntax here, we can go ahead and take a look at this. It enables you to query a type by writing one or more values in square brackets after the instance name. So here we go. We have a subscript here. And if we go ahead and we throw this into our playground, you can see that, let's go ahead and repaste that. Here we go. Subscript index integer. It returns an appropriate subscript value here, right? So this is just more of a template for how you would build things out. You also can build out a read-only computed property to simplify the declaration. So in this particular example here, you can simplify the read-only subscript by removing the get keyword. So up here, you can see that there's a getter here, but in this example, this will make it read-only by using this syntax. So here's actually an example of a read-only subscript implementation, which defines a times table to represent in times table of integers. So we go ahead and first put in the struct here. Let's go ahead and take a look at this struct timetable, and we have a let multiplier, and then we have a subscript inside of here. And so what we can do is to actually use this, I can define a 3 times table right below here. And let's go ahead and do that. That works. And then I can actually execute this by doing a print. And notice I access the subscript with the 3 times table, put the square brackets, and then do the 6. And you can see 6 times 3 is 18. So in this example, the new instance of times table is created, and it represents the 3 times table. So what about usage? The exact meaning of subscript depends on the context. They're typically a shortcut for accessing the member elements in a collection, list, or sequence, but you can implement subscripts in the most appropriate way. So for example, the Swift dictionary itself implements a subscript that can set and retrieve values in a dictionary instance, and you can set a value in the dictionary by providing a key of the dictionary's key type. So here we go. We can go ahead and take a look at how a dictionary works. If I paste this in here, we do var, so it's going to be a mutable dictionary here, and we say number of legs right here. We do key value pairs, right? Kind of a classic dictionary style. Once we set that, if I want to access a particular element of this dictionary, I would use this subscript syntax. So here we go, access this dictionary and mutate it. Dictionary and mutate it, right? So we want to add some value to it. And now we've got, if I go ahead and I say prints number of legs, we should see that, in fact, the bird has been added to the dictionary. This is actually almost identical. If actually, I think it is identical to the way it works in Python. So what about options? Subscripts can also take any number of input parameters, and these can be of any type, like functions. A subscript can take a varying number of parameters as well. So you don't have to have a fixed number of parameters. So here's one. This is a a subscript that commonly you do a single parameter, but you can define one that has multiple parameters if it's appropriate for a type. And so in this particular example here, I guess the subscript takes both a row and a column. And this matrix subscript takes two integer parameters, right? So the row is integer, the column is an integer. Okay, let's go ahead and throw this down right here. And let's take a look. And you can see first the struct is created. Then there's a function which is index is valid. And then the subscript here is now set with two different integers that are created. If I go ahead and I run this, we've got this thing working. Now, if I want to actually construct a new matrix, I can actually do this as follows. Here we go, var matrix. And again, I give it both the row and I give it the column. And then if I want to print that out, we can go ahead and say print matrix. And there we go. We have a matrix that has two rows, two columns, and here's the grid. So kind of a cool example there. And then if I wanted to set, basically particular elements of the matrix, I guess, what you're doing in this particular scenario is building, really the equivalent of something like NumPy in Python here, making a multi-dimensional array. And I think here we don't need this. There we go. And if I go ahead and I say print matrix, should go ahead and get this. There we go. Perfect. We've got this matrix set here. Now, if I want to check things like, for example, the matrix subscript getter and setter both contain an assertion to check that the row and columns are valid. And so what we can do is we can actually say, let some value matrix to 2. So we want to, this triggers an assert because this is outside of the matrix bound. Let's go ahead and try that out. Say let, and let's see if it blows up on us. And in fact, it does. It says, sorry, assertion failed. So that's a neat little example there, actually, for someone wanting to build their own matrix. And we also have type subscripts here as well. So an instance subscript is something that you would use in order to basically work around an instance of something and kind of make it do what you want. In this case, there's a planet. We have case statement here, and this will return back a subscript. We'll go ahead and run this, and we say let Mars equal planet 4. So we'll make Mars planet 4, and then if we go ahead and we print Mars, you can see that in fact it is able to return back. It is able to return back Mars, and we've been able to get that value set. So definitely an interesting style of Swift here. I will definitely be playing around with that a little bit more. I like the examples they gave to us. All right, so that's pretty much it for today. And next week, I'm going to continue on building things out. I'm going to talk about inheritance next week. So I will see you next week. All right, bye.